Hello wonderful person, this is Anton, and today we're going to be talking about this very unusual observation of the effect created by the Large Magellanic Cloud as it passes by the Milky Way galaxy, with the LMC as it's known, with the Large Magellanic Cloud, or LMC as it's known, being the nearby dwarf galaxy that essentially orbits around the Milky Way. But the discovery itself is actually really important in helping us understand the presence of the mysterious dark matter as well. First of all, let's start right here. What this image shows you is the presence of the so-called galactic halo. This contains a lot of gas, this also contains a lot of different stars, but it also contains tremendous amounts of the mysterious dark matter. Something that is not truly understood just yet, and something that does help us explain how the universe behaves and how galaxies behave as well. A lot of different computer simulations that scientists have performed definitely require the presence of dark matter to try to explain the universe that we actually see in real life. Like for example, the Illustris project, the simulations from which I'm showing you here, depends on dark matter to explain the galactic shapes and galactic features that we observe everywhere around us. But all of these simulations also usually create a kind of a halo around a typical galaxy, something that we refer to as the galactic halo. But because all galaxies will have these halos and also some galaxies will interact with these halos, it's quite possible for us to start predicting what effects some of these nearby galaxies might have on the halo of the Milky Way galaxy. Now we have two candidates here. We have the Large Magellanic Cloud that you see right here, and its slightly smaller partner, Small Magellanic Cloud, that's visible right there. Now, the scientists in the past used various simulations and predicted that as LMC, or Large Magellanic Cloud, moves through the halo of the Milky Way galaxy, it should actually create a kind of a wake, basically kind of like a boat moving through an ocean. So something that might resemble this, but here we're talking about much bigger galactic-sized shapes. And the simulations did show that this wake should be visible from a very large portion of the night skies, and it also should have a very specific shape based on the orbit of the Large Magellanic Cloud, with the shape itself resembling something like this. Now what you're seeing here are basically two regions, one really large dark matter region and a halo region in this location, and one slightly more disturbed region right here, with the Large Magellanic Cloud following this path right here. Here's what this looks like from a slightly different perspective. And this was based on the simulations of what would happen if LMC passed next to the Milky Way galaxy. But naturally, because these are simulations and not actual observations, the scientists now have to try to confirm this by finding something else out there that actually confirms their hypothesis. And to do this, since we can't really see dark matter, they would have to find something else like stars or maybe gas in this region that would form a relatively similar shape. In this particular case, they actually refer to this as the presence of a local wake, the wake here being this shape, and the presence of a local overdensity, which is this right here, similar to this region right here, where the waves sort of form a slightly higher density than the region nearby. But up until now, this wasn't that easy, or I would even say it was actually impossible, mostly because there are just too many stars out there and too many different reasons for why measuring distances to those stars would be very difficult. So even though the computer models were pretty clear at what we should be seeing, it was almost impossible for the scientists up until recently to try to prove any of this. But in the last few years, both NASA and ESA released a tremendous amount of data with a lot of different stars and their measurements, including the distances to those stars. For example, we have a lot of really accurate observations from NASA's mission known as NEOWISE, with something like 9 years of data between 2009 and 2018, and also a lot of really accurate observations from missions like ESA's Gaia telescope that essentially allows the scientists to calculate precise distances to pretty much most of the stars nearby and some of the distant stars as well, which in the last few years allowed the scientists to very accurately literally scan the night skies and determine distances to a lot of different objects out there, distances that were previously unknown to us. And by using roughly around 1300 stars mostly located in this region you see right here, the scientists behind the study discovered something really interesting. They discovered the wake is indeed there, as is the overdensity that's formed by the wake itself, with all this located at a distance of about 200 to 350,000 light years away from planet Earth and from Milky Way itself. Or in other words, it's literally showing us the path that Large Magellanic Cloud took to approach the Milky Way galaxy. It also indicates that this seems to be the first orbit of the galaxy around the Milky Way. And what's really interesting here is that it's literally showing us that the galaxy, as it approaches the Milky Way, seems to pass through this invisible halo, and the halo seems to tug on it, which essentially results in the galaxy slowing down and assuming an orbit around the Milky Way. Or in other words, as LMC entered the region around the Milky Way, it literally hit the halo of dark matter, which then started to pull on it and then started to slow down the galaxy as it moved closer and closer to the Milky Way. At some point, it's going to slow down so much that it's going to fall into the Milky Way, eventually becoming a part of our own galaxy as well. And if it wasn't for the dark matter halo, and if it wasn't for the interaction with this really large, very massive formation surrounding the Milky Way galaxy, it would be really difficult to explain the path that the LMC seems to have taken. So this overdensity that you see in this picture seems to be a pretty good explanation for the projected path of Large Magellanic Cloud as it moves in the region around the Milky Way. But since the current distance to LMC is about 160,000 light-years, it means that it's probably going to make a few orbits around the Milky Way before it finally crashes right in the middle and basically becomes a part of our own galaxy. But as it sails across the space, it very likely is going to disturb other regions of the halo as well, eventually sort of creating a kind of a spiral-like structure in the middle. Or at least that's what I kind of think is going to happen. It's still not really known to us how these galactic interactions change the halo of the galaxy, or how they influence the dark matter around the galaxy itself. And since Large Magellanic Cloud is the most massive galaxy nearby, and is the one that's probably going to cause the most gravitational interactions with the Milky Way, it definitely presents a perfect opportunity to study the galactic interaction and various types of dark matter interaction when galaxies collide. But it's also important to remember that what we're looking at and what we're actually seeing is not really the mysterious dark matter. These observations are of actual stars in the path of the Large Magellanic Cloud as it moves across the universe. And so in some sense, these stars can also be seen as tiny little particles floating on the surface of the water, with the water itself here representing the dark matter. And so even though we're seeing the particles on the surface, we're not actually seeing dark matter itself. But it does help us understand, and also helps us visualize, how these different halos interact when two galaxies collide, and also helps us understand what sort of structure this halo has to begin with. Because even though we have images like this from the Sombrero galaxy, here it doesn't really help us visualize the larger halo around the galaxy. It really only shows us the inner location of the inner stars. But the entire halo is very difficult to see usually, and it's also extremely difficult to try to determine the location of dark matter as well, which is something that a lot of scientists are really desperately trying to figure out. Nobody still knows what it's made out of, nobody still knows if it even exists, but so far it still presents the best explanation for a lot of things we observe in the universe, including the effects that the LMC is experiencing as it's entering the Milky Way region. Because the only reasonable explanation why Large Magellanic Cloud has this very unusual pathway as it comes closer to the Milky Way is if it was entering a region with these invisible, very massive particles that were sort of dragging on it, kind of similar to how things slow down when they enter water as well. And so just like the water slowing down these strawberries as they fall into this bowl, as the LMC galaxy entered the Milky Way region, it experienced a very similar slowdown. And the only reasonable explanation here is of course the presence of dark matter. And because these types of collisions is essentially how all galaxies seem to grow, we definitely need to try to understand them a little bit better. But by explaining this with dark matter halo, it definitely makes a lot more sense. And what all of this means for the Large Magellanic Cloud is that in approximately 2 billion years, the dark matter is going to slow it down just enough for it to finally combine with the Milky Way. But assuming that this study is indeed correct and everything discovered here is indeed a good representation of the dark matter halo and the observations that the scientists predict in this paper, what this study allows the scientists to do now is to use the properties of the observed wake to try to figure out what sort of a theory would apply best to try to explain dark matter. And so by studying the shape of the wake and by trying to determine the exact amount of overdensity here, the scientists can finally try to work out what creates the dark matter and what sort of particle is responsible for basically making all of this happen. And so overall, a really cool discovery. With the other major discovery coming out of this paper is that, as I mentioned, this is the first orbit of the LMC, and it's very likely that this galaxy was originally created about 13 billion years ago, possibly somewhere close to the Andromeda galaxy, or maybe somewhere between the Andromeda and the Milky Way. And so technically, it's still sort of orbiting the Milky Way galaxy, but with every orbit now, it's only going to be approaching closer and closer. And by the way, in case you're wondering how exactly they were able to measure the distances so precisely, especially because we're talking about distances of about 300,000 light years away from us, they used the type of a giant star known as RR Lyrae. These are pulsating stars that tend to change their luminosity in a very predictable way, and because of this change in luminosity, it's usually quite possible for scientists, for astronomers, to work out exact distances to these stars. The scientists in this paper were able to use about 1300 of these stars to create a relatively precise 3D map of the region left behind by the LMC galaxy. And that's the map that you see right here. And so it's a very accurate and somewhat interesting study that will allow us to study the regions around the galaxy in a lot more detail with some of the follow-ups as well. But for now, that's kind of all the scientists discovered. Definitely a cool confirmation of the existence of dark matter, also a really cool analysis of the motion of Large Magellanic Cloud around the Milky Way, but more studies are needed to discover other things as well. On that note, subscribe because there are going to be a lot more videos about these follow-ups, and share this video with someone who loves learning about space and sciences. Thank you for watching. Maybe support this channel on Patreon by joining the channel membership or by buying the wonderful person t-shirt that you can find in the description, and maybe come back tomorrow to learn something else. Either way, stay wonderful, and as always, bye-bye.